Hi friends, and welcome to this session on roots and networks. If you see past year's CSAT paper or bank PO paper or any other SSC paper, you would find one or two questions in 1 or 2 years, right? So it's not always there, the question is not always there, but there is a good possibility that you would get a question on roots, right? So there are no basic fundas as such in these questions. These are very logical questions and based on your perception and your analysis at that point of time, and nothing more than that, right? There can be few concepts of permutation and combination which we have already seen in the chapter of permutation and combination, which can be applied to the question of roots, right? Apart from that, it's just common sense, right? So there are no basic fundas, or if we can say there is just one basic funda. There can be two type of arrows, right? There can be this arrow which shows one directional flow, there can be this arrow which shows two directional flow, or there can be a simple line which shows, again depending on the question, a unidirectional or a bidirectional flow, right? So roots and network means there are routes of roads, right? As we know, there are routes of roads. For example, if you want to go from Bombay to Pune, there can be multiple routes which can lead you to Pune, right? And there are certain nodes where these routes merge, right? For example, if this is Bombay, there is one road which goes this way, there is another road which goes this way, right? Reaches a junction here, it reaches a junction here, and then they merge at a toll plaza. Let's say this is a toll plaza, so they merge at a toll plaza, and after that it directly hits to Pune. Or there can be two other way outs which hits to Pune. There can be this road or there can be this road. So this is basically route of roads, right? And then there can be route of pipelines as well, right? So if you see the CNG pipeline or the LPG pipeline in big cities, it also follows some route, right? There is a station here, right? And it lets the pipe the pipe which is laid there for the gas has certain capacity, right? And this pipe then goes to various flats. So there are smaller pipes which has lesser capacity, right? So this is one pipe which goes to one flat, this is another pipe which goes to another flat, and so on and so forth, right? So this is again a pipeline. Then there can be a network of electric circuits, which I'm sure many of you have done in your class 9th and 10th, where we see resistances in parallels and in series, right? Which is slightly out of scope of this chapter, right? Which they would never ask, because they are not going to ask physics as such, right? So let's see few questions and understand what kind of. So these are basically CSAT questions. I've taken CSAT questions to put things in perspective. So let's see what CSAT asks from roots and all that stuff. Given the diagram of the road network, where should the lamppost be placed so that it gives light to all the towns? So there are few options, and this is the diagram which is given, right? So 1 2 3 4 5 and 6, right? So if we place, let's see, if we place without looking at option, can we solve it? If we place a lamppost at 6, it is connected to 4 only, right? So it would give light to 4, right? So we cannot place lamppost at 6 and 1, right? We have to place lampposts at so if we place lamppost at, let's say, 1, it would light up what, 2 and 4, right? Now we are left with 3 4 6. Where should we place then? We should place at 4, right? So we can place at 1 and 4. We can also place at 4 and 2, right? If we place at 4 and 2, we would get light in all the towns. Can we place at we can place at 5, right? If we place at 5, we would get light in 4, 2 and 1, right? Then 6 would be left. Then we can place at 4, right? If we place at 4, we would get at 3 and 6, right? So we can place at 5 and 4. So let's look at options and see where we can place. Can we place at 6 and 1? We have already seen we cannot. Can we place at 1 and 3? If we place at 1 and 1, we would get light 2, 5 and 1, and we would light 4, 2 and 3, but 6 would be left behind, right? So 1 and 3 is not possible. Can we light 4 and 2? Yes. If you see, 4 would give light to 6, 5 3 and 4, 2 would give light to 3, 5, 1, right? So 4 and 2 is the right answer. As you see that it does not require any conceptual knowledge as such, but you have to comprehend the question really well and you have to perform at that point of time, right? So this is it. This is about this question, right? So if you can see this is a 2 by 2 square, right? And there is a point A here and B here. We have already done this kind of question in our permutation and combination. So let me redraw it to a darker one. So it is, the roads are like this. There are the vertical roads and horizontal roads. You have to go from A to B. In how many ways can you do that, right? One way out is you name this C, this is D, this is E, F, G, right, H, I, and then B, right? And now you start routing them. So there can be A, C, F, G, B. This is one route. Then there can be A, C, D, G, B. This is another route. Or what we did in our permutation and combinations, it's a better way out. So what we said there was that we need 2 horizontal moves because B is 2 times horizontally away and 2 vertical moves to reach from A to B. So this is just a combination of H, H, V, V. So how many combinations would be possible? It would be 4 factorial. So 4 factorial divided by 2 factorial, because they are repeating. So divided by 2 factorial by 2 factorial, which is equal to 24 divided by 4. There are 6 ways. If you just plant the ways, you would find there would be only 6 ways. So here you have seen that our concept of permutation and combination has worked, right? Now this again is a question which appeared in CSAT, right? I'll tell you the year. I'll just check the year. So it happened in CSAT 2013, right? This was a simple question. There were three questions which followed the instruction set. All 3 were simple and you would have got all 3 right. So there are 5 cities connected by different modes of transport, P, Q, R, S, T, right? Then there are modes of transports which are given here. P and Q are connected by boat and as well as rail, right? Then all the other things are given. S and R are connected by boat and bus. Q and T by boat and bus and boat, right? So Q and T and S and R are connected. So this is wrong, I suppose. I just checked the question. This is by air. The question says Q and T are connected by air, right? P and R are connected by boat. T and R are connected by rail and bus. So you have to answer few questions, right? First question says, which mode of transport could help us one reach to R starting from Q without changing the mode of transport? So you have to go from Q to R without changing mode of transport, right? So you can go from, let's see how are they placed, right? So P and Q are connected by boat as well as rail, right? So there is this two-way connection, right? So we'll not put any arrow and we assume that it is two-way connection. P and Q are connected by R and B, rail and boat. S and R are connected by bus and boat. Let's not put S and R abhi, we'll put it later. Q and T are connected by air. So Q and T by air. R and P are connected by boat only. So R is here by boat only. And finally R and T are connected by, so this is rail and bus. So we'll denote bus by BU. We left one statement which was S and R are connected by bus and boat. S here, bus and boat. So this is the diagram which we would get after reading all the statement. So bus and boat. Now which mode of transportation would help one reach to R starting from Q, right? So starting from Q, how can we reach R? We can reach R via P only, right? Or we can reach R via T and then we can reach R. So we can reach R in two ways, one via P and one via T. So if we reach R via T, we can take boat as the medium and we don't need to change the medium. But when we try to reach R by T, we have to change the medium, which is not what is required in the question. So by a boat we can reach R without changing the medium. So answer should be boat. If a person visit each of the places starting from P and get back to P, which of the following should he visit twice, right? Let's go to the figure. So he has to visit all the places starting from P and then he gets back to P, right? So how can he start, right? So for example, he go to firstly R, then S. Now he has to come back to R, right? So which means R is a probable choice. Now let's see if he does not take this route. He takes P to Q, Q to T, T to R, R to S. Now he has to come back to P, which means he again has to come back to R, which means in both the cases R is the position where he has to come twice. So R is the answer in this case. The next question says, which one of the following pair of cities is connected by any of the routes directly without going to any other city? P and T. Is P and T connected directly? No, it has to go to Q. Is T and S connected directly? No, it has to go to R. Q and R. Let's see, Q and R is not connected directly but through P, which means the answer choice is none of these. Right? So see, these are the very easy type of questions which appeared in the exam. Between the two cities, amongst the pairs of the cities given below, there are maximum, where are the maximum number of traveling options? So we work with options only. So Q and S. Q and S, it can go through. So from Q there are two options, Q to T, Q to P, and then P to R, R to S, right? Or Q to T, T to R, R to S. So when they are talking about maximum options, they are mostly talking about the shortest possible options. So there are two options from Q to T, Q to S, right? P to R, P to R, there are again two options, right? P to T, let's see, P to T. P to T, again there are two options, right? And Q to R. So Q to R, again there are two options, right? So two options, when we are saying, we are assuming that we can travel only one way, but from P to Q we can travel in two ways as well, right? We can travel either through rail or through boat. So there are two options. Had it been a single way out, we have seen that there is only one option to travel from each of them, right? So now we know that there are two options, right? So from Q to P there are two options to travel, right? From Q to P there are two options. From if it goes via T, again there are two options, right? So which means that most probably the answer choices with Q are to be selected, right? So let's check for Q to S and Q to R. So when we go from Q to S, there are two ways. First, from Q we can go to P in two ways, right? And then from P to R, R to S, again from R to S in two ways, right? So which means there are lots of options. Now if we take Q to T, then T to R there are again options, and R2S there are again options. So there are lots of options. Let's not number the options. So Q to S seems to be a good answer. Let's see Q to R. So Q to R is one node less, right? So Q to R is one node less. When we added S, we added two options more, which is boat and the bus option. So which means Q to S is greater than Q to R. So our answer choice is Q to S. Next question is CSAT this year. With reference to the figures given below, what is the number of routes from S to T such that we don't have to retrace either U or V. So from S we have three options, right? If you see, we can go here, here, here. Three options to reach U. Once we are here, we have two options, right? So this is our basic principle of multiplication, right? This option would lead here, and we would reach V in two ways. Now from V to T again we have three options. So finally our answer is 3 multiplied by 2 multiplied by 3, which is 18 ways, right? If you know the basic principle of multiplication and what we are doing here, this question becomes very easy. So answer would be 18. Questions on roots can be very tough as well sometimes. So if you see paper of CAT or something like that, you would see really tough questions on roots and networks. But hopefully, and as the past trend suggests, in CSAT the questions on roots and networks are not very tough, right? Now the last set which we are doing here, so that we understand the concept really well, is about the transportation of fuel, right? So A is a reservoir, let's say, and from A we have to fulfill these centers B, C, D, E, right? So these are the fulfillment centers. The conditions given are each of the pipeline can carry up to 1000 gallons of whatever, but pipeline between B and D carry only 300. So this one carry only 300. This is the maximum capacity which is given, right? So maximum capacity of this is 1000. Let's not write it because they may carry less or more, right? The maximum capacity of this is 300. Now let's see questions. If the requirements of B, C, D are 400, 200 and 200 respectively, what can be the maximum fulfillment for E, right? So it is 400, 200 and 200, which means this is 400, this is 200, right? And this again is 200. Now since we have to maximize the thing, let's see what can be carried here maximum, right? Here there is no constraint, so it can be 1000, right? So 1000 goes there, 200 is absorbed here, and 800 remaining goes to the next one. Now if 400 is observed here and only 300 can go here, right? Which means this pipeline can carry only 700, right? It cannot carry more than 700. 400 is absorbed here, 300 is left, again 200 is absorbed here, 100 goes here, plus 800 from here, right? 800 from here. So total maximum of 900 gallons or 900 units of oil can reach E. So E can have maximum fulfillment of 900, right? So this 300 has constrained the capacity of pipeline between A and B. So you have to appreciate and understand that, right? So this is our first question. Now let's remove what we have written, because second question might be different, the values might be different, right? Second question says, if it is known that A and B has the line between A to B has free capacity of 200 and line from B to D has no free capacity, then what is the requirement of B and D, right? So this is a little bit ambiguous question. It says that it has A to B and free capacity of 200, which means it is carrying 800, what could be the capacity of B? So it has to be 300 maximum, so it is 500, and this is 1000, right? There is no slack, but we don't know the capacity of C, so we cannot comment on capacity of D. But what we can comment is capacity of B can be 500, right? Because if 800 is going here, it cannot be 400, it cannot be less than 500, right? It can be greater than 500 though, right? So if there is an option that capacity of or the requirements of B is greater than 500, that can be a right answer. Or if there is an option that the requirement at B is 500, that again can be the correct answer. But for D, the answer would be we cannot determine it, right? So as you see that things can become all the more complicated if we want to make them complicated, but good thing is if you practice these kind of questions, you would be able to crack them. But still there can be sets which you might not be able to crack, and thankfully they don't come in exams like CSAT or SSC, so you don't have to worry about those kind of sets. So this is about all about roots and networks. I hope that you understood the topic and you enjoyed the video as well. Thanks for watching this video, and all the best for your preparations.